All right, so ladies and gentlemen, this particular video is focusing on the second FRQ for the 4 review FRQs that I posted. This one's a little bit shorter than the first one, so actually I'm going to talk about the solutions and I'm going to talk a little about how it was scored so you can get an idea of what it looks like to score kind of an AP exam, what the readers are looking for. So, to start with, let's go by looking at the beginning of this. So hopefully you've had a chance, and if you've not already done so, you need to pause the video right now and attempt to solve this question. All right, that's the best practice I'm going to tell you that I'm going to give you, I promise. So let's talk about this question. This one is similar to, this will be the shorter of the two questions. So in the AP exam, you're going to have a long question that's 25 minutes, it'll be about 25 minutes, and a short question that's about 15 minutes. In this case, this is similar to something you might see, which is an idea where you're going to have maybe an experiment with something slightly different, and you're going to have to talk about what's happening between the two objects and identify physics-wise what's going on between them. So in this case, I start with, we have two groups, and if you hopefully read through this so you understand what's going on. We have two groups. They've set it up so that they both have a slide. And the slide is kind of a bit differently on each table depending on what's going on, because in this case, one table is shorter than the other one. All right. Now what we want to know is that I'm going to let both blocks go at the same time. And my question is, does each block land the same distance from their respective tables? All right. Now, hopefully you had a chance to look through this, and there are a couple things we want to acknowledge before we answer this. The first thing is because I have this weird kind of surface, the best tool to evaluate this is going to be energy. All right, whenever you see a strange surface that isn't uniform, you probably want to use energy so that you can ignore all the weird curvy parts. So let's start at the beginning. If we look at block 1 and block 2, you'll notice the drawing both says the slide is a height of D. However, that is actually slightly misleading, because you'll notice if you look at the true height from the floor, block 1 actually starts at a greater height than block 2 does. Because of that, block 1 is going to start with a little bit more potential energy than block 2 does, and that's going to be important when we get to the second part. So block 1 starts with more energy than block 2 does, potential energy anyways. Then when I let them go, they both leave the table from the same height. Now, of course, because table 2 is a little bit shorter, they had to adjust the slide, which means that if we look at block 2, it actually ends up with less kinetic energy than block 1 does when it leaves the table. When block 1 leaves the table, it's fallen the total distance d, so a bunch of potential energy gets turned into kinetic energy. But when block 2 leaves the table, it had to raise up its height a little bit, so in order to leave the table at the same height as block 1. So in fact, some of its energy went back, some of the potential energy that might have gotten converted into kinetic got turned back into potential energy a little bit before it left the table. So this long explanation can be broken down into this. Block 2 has less kinetic energy when it leaves the table than block 1. So it will actually fly a little bit less. Its distance will be shorter than block 1 will because its horizontal velocity is less. So the answer for A is no. You'll notice I wrote a very long explanation. I'm a physics teacher. I'm going to do that. If you basically said something along the lines of block 2 starts with less energy than block 1, and it leaves the table with less kinetic energy than block 1, bam, that's perfect. That's exactly what you need. All right? Now, second piece of this. Now we reset the tables, we reset the tracks. So now they're all at the same, they start at the same height, the tables are the same height. I'm going to let them go at the same time. And it's two pieces to this question. We'll talk about the first one to start with. So I want to know, once again, it's the same kind of question from before. Which block is going to land farther from the table? And looking at this, if we go back to the energy argument, the starting energy of block 1 and block 2 is exactly the same. They both have the same potential energy. The final energy right when they leave the table is also going to be the same, because they still have some potential energy because they're at the same height. But they also now have the same amount of kinetic energy because they've fallen the same distance. So, because of that, block 1 and block 2, which are identical, have the same kinetic energy when they leave the table. Because of that, that means they're going to be moving at the same launch velocity when they leave the table, and therefore they're going to go the same horizontal distance before they hit the ground. So right there, for one, they're actually going to land the same distance from their respective tables. All right, and once again, I gave a very detailed explanation. You can say something along they have the same starting energy, same final energy, so their launch velocities will be the same. Something along that line that explains it. The way you get points, or the way you lose points, really, is to not give a physics reason for an answer. All right? Now, the last piece of this before we talk about how I score it. Which block is going to hit the floor first? This question is a little bit weird because there's not really a great physics law that explains this. Instead, we want to think about the idea of really average speed is what the score sheet will talk about. Honestly, you want to think about which one is going to reach its high velocity first. All right. If we look at the two blocks, when I let go of them, block 2's slope is gentle. So it's not moving super fast in the first part. Block 1, on the other hand, has a very steep slope to begin with, so it's going to start moving very quickly early on. That means because of that, block 1 will be able to cover more distance in less time because it's already moving faster than block 2. Now, by the time block 2 gets to the bottom, it'll have the same velocity as block 1, but it takes more time to get to that. So because of that, block 1 is actually going to reach the end of the track first because it's going faster. It goes at a higher velocity earlier on. All right? And that's a weird thing to think about. I'm going to have to kind of tell you to take it on faith right now. If you do some calculus, you could probably take derivatives of the slope or whatever. Don't worry about that. But it just comes back to the idea of average speed and the fact that block 1 reaches a high velocity quicker than block 2 does. All right? Now, bonus question is that when you're looking at this, it wants to try and trick you because once the blocks leave the table, if I was only timing how long it took to hit the ground from once it left the table, it wouldn't be any different. Because as soon as it leaves the table, the blocks are the same. They're both in free fall. So the time of flight, the amount of time it will take to hit the ground will be exactly the same. But block 1 takes less time to go through the slide than block 2 does. All right? So now, I'm going to check my time real quick, make sure I'm doing good. Yep, I'm doing great. Let's talk about how this is scored. So on the AP exam, what happens is the graders basically sit here with this score sheet and they look at your answers and they see what you have and if you were in agreement with them or disagreement, and they try and award points accordingly. So for this one, if we're looking at the first question, this is part A. This is worth 3 points. Right away, you get points if you give the right answer. And if you give the wrong answer, if you give an explanation that uses physics to kind of justify it, you can still get partial credit. So, if you answer no, and then they're looking for 3 things. First, they kind of talk about the idea, you bring up the idea of energy. All right, talk about energy, that's a point. Then, if you talk about the fact that one of them leaves the table going a different velocity than the other one, that's another point. So if you said something along the lines of, oh, the launch velocity is different, boom, that's perfect. Third, it says for stating or implying the time to reach the ground is the same for both blocks. You could talk about that if you want to be very specific. So basically saying that it'll leave the table at a slower velocity, but the time it takes to hit the ground is the same, so the delta x is less. More than likely, it'll probably, if you bring that up, it'll already be assumed, but that's just kind of what they're looking for. But this gives you an idea of how specific they want you to be sometimes. And I know I sometimes give misleading information because I say, you don't have to write a ton of stuff. It really depends on what they're looking for. All right? So, when in doubt, don't write a ton of sentences, but definitely point out various physics things. All right? So, part A right there. That's how you score it. 3 points. All right? The other part, there are 4 points. And it's split between the 2 different parts. So, the 4 points are really for you give the right answer. And even remember, you can still get some partial credit even if you don't give the right answer. But to get full credit, you probably need to give the right answer. But right away, 2 points for basically saying that they land the same distance. 1 point for basically identifying the fact that they have the same, that their energies are kind of the same. 1 point for talking about the fact that that means the launch velocities are the same. So as long as you literally say, oh, they have the same start energy, same final energy, and they leave the table at the same velocity, that's 2 full points right there. And then for the last part, you kind of get the same idea. You pick the answer, and then you basically talk about the fact that anything along the lines of, oh, it reaches a faster speed earlier on. They talk about average speed. Just because the scorer is looking at these answers does not necessarily mean your answer is wrong. All right, and I want to make that very clear when you look at the score sheets. There can be more than one way to answer this. So you answer with whatever you feel most comfortable giving an answer with. Right? If you're comfortable using kinematics and you're good at explaining that, you don't necessarily have to try and force everything into energy just because you think that'll work better for this situation. Use what works best for what you know. Don't panic, and you will be fine. I promise. And never forget, whatever happens during this exam, my salary is not at all tied to this. I keep bringing this up. I will still be here next year. Don't worry. All right. So with that being said, ladies and gentlemen, that's kind of the explanation for how to go through FRQ number 2. If you have any questions, shoot me an email or come talk to me during office hours. And then over the next couple days, I'll post the solutions for FRQ 3 and 4. All right. So with that being said, ladies and gentlemen, have a great rest of the day, and I'll talk to you later.